Hi and welcome back to module number 7. For quick knowledge check, we are covering Amazon Cloud Architecting certification, and this module number 7 talks about creating networking environment. We'll go through the right answers and we'll give explanation of the right and wrong answers. So let's read the question number 1, which definition describes a virtual private cloud. So the best definition for that one is a logically isolated virtual network that you define in AWS Cloud. So when we talk about a VPC, think of it as your own private section within the AWS Cloud. It's logically isolated, means it behaves as if it's your own private network. Even though it physically exists in AWS infrastructure, you control everything from IP addressing to subnet, routing, and security. It's your own virtual data center in the cloud. Now let's go through the answers which are available over here and why we are not selecting them. So first of all, we have an option of a virtual private network in the AWS cloud. This is not a VPC. A VPN is a secure connection between networks, not the network itself. The second option talks about a fully managed service that extends the AWS cloud to customer premises. This is not the right answer because that describes AWS outposts, not a VPC. And we are not selecting the third option as an extension of an on-premise network into AWS because that's a hybrid setup using VPN or direct connection, not the definition of a VPC itself. Now, question number 2 says, which component does not have direct access to the internet? So the right answer for that one is EC2 instance inside a private subnet. The reason for that is instances in private subnets are intentionally kept away from the public internet. They can still reach the internet indirectly using a NAT gateway if needed, but they can't be reached from the outside world. This makes them perfect for backend servers or databases. Now let's go through the other answers. The first available option was elastic IP address interface. This is not the right answer because that's publicly routable. It provides direct access to the internet, so we can't select that. Then the second option is EC2 instance inside a public subnet. This is not the right answer because public subnets are designed to be internet accessible, and we are not selecting the NAT gateway inside a public subnet as well because the NAT gateway connects to the private subnets to the internet, so it clearly has internet access. Question number 3 says a company virtual private cloud has the classless internet interdomain routing, which is CIDR, block for 172.16.0/21. It has 2 subnets A and B. Each subnet must support 100 usable addresses now, but this address is expected to rise to most 254 usable addresses soon. Which subnet addressing scheme meets the requirements and follows AWS best practices? So the right answer for this one is subnet A, which is /23. The choice provides enough IP addresses, more than the current 100 required, and room for growth to 254 per subnet without wasting space. Using /23 subnet balances efficiency and scalability while keeping the network structure tidy and aligned with best practices. Now let's see the other options. If we are going for /22, this is not the right option since it's too large for the current and future needs. It wastes address space. We are not selecting /25 address. The reason is that it's too small. It wouldn't handle the expected 254 hosts. And we are not selecting /24 because it might work now but lacks headroom for growth, not an ideal option for scaling. Next is question number 4. Several EC2 instances launch in a VPC that has internet access. These instances should be accessible from the internet, but they must be able to download updates from the internet. How should the instances launch? Now, the right answer for that one is that without public IP address in subnet with a default route to a NAT gateway. The reason is that the setup keeps your instances private while still allowing them to reach the internet for things like software updates. The NAT gateway handles outbound requests and hides the instance's private IP addresses to the external addresses. Now, First of all, we are not selecting with public IP addresses and subnet with default route to the internet gateway. The reason is that makes the instances publicly accessible. The other option is that without public IP addresses in a subnet with default route to an internet gateway is not a right option because they couldn't connect at all. There is no NAT translation. And the last option of with elastic IP address in a subnet with a default route to an internet gateway is not the right option because elastic IPs are public. That breaks the not accessible from the internet rule, which is mentioned in the question. Question number 5 says a group of consultants requires to access to the EC2 instance from the internet for 3 consecutive days each week. The instance is shut down, the rest of the week. The virtual private cloud has internet access. How should you assign one IP4 address to the instance to give the consultants access? So the right answer for this one is associate an elastic IP address with the EC2 instance. The reason is that elastic IPs are perfect when you need a consistent public IP address that you can reuse. The instance can be stopped and started anytime and IP stays yours, ideal for intermittent consultant access. Now let's see the other options. For example, the first option of enable automatic address assignment for the subnet, that's a wrong answer because that gives dynamic address, not fixed. Then we are not selecting the second option which says enable automatic addressing assignment for the EC2 instance. Same issue, it changes on reboot. And we are not selecting the third option of assign an IP address in the operating system boot configuration because that's static inside the operating system but doesn't expose it publicly through AWS networking. Question number 6 says an application uses a bastion host to allow access to the EC2 instance in a private subnet within a VPC. What security group configuration should allow SSH access from the source IP to the EC2 instance? So we have 2 right answers for this one. The first right answer is add a rule to the bastion host security group to allow the traffic on port 22 from your source IP address. And the second right answer is add a rule to the EC2 instance security group to allow traffic from the bastion host security group on port 22. Now the reason is that this is a standard on a bastion setup. You will have SSH into your bastion from the IP address and then the bastion to SSH into the private instances. The first rule lets you reach the bastion. The second would let the bastion reach the private servers. Now let's see the other options. For example, the first option that we had over here was add a rule to the bastion host security group to allow return traffic to your source IP address. That's not the right option because that's handled automatically for established connections. We are not selecting the second option of add a rule to the private subnet EC2 instance security group to allow return traffic to the bastion host security group. The reason is that return traffic doesn't need an explicit rule. And we are not selecting the third option over here says that add a rule to the bastion host security group to deny all traffic from the internet. The reason is that would block even your SSH access. Now question number 7 says a solution deployed in a VPC needs subnet with limited access to specific internet addresses. How can an architect configure the network to limit the traffic from and to the EC2 instance in the subnet using the network access control list? So the right answer for that one is to add a rule to the subnet custom network ACL to allow traffic from and to allow internet access. Reason is when you need fine-grained network control, use custom access control list. You explicitly allow only the IP range that you want to allow to trust and deny everything else. This ensures that only specific sources and destinations can communicate with your subnet. Now, we are not selecting the first option which says that add rules to the subnet custom access control list to allow traffic from and to allow internet addresses, deny all other traffic. The reason is that ACLs are stateless, so adding deny all to other traffic isn't needed explicitly. It's implied once no matching rule exists. And then the other option is that add rule to the default network ACL to allow traffic from and to the allowed internet addresses. The reason for this one that it is a wrong answer because default ACLs are shared and not ideal for restrictions, for example, to use custom ones. And then we are not selecting the last option to add rules to the default network ACL to allow traffic from and allowed internet addresses, deny all other traffic. The reason is that it is not considered to be the best practice and it could disrupt other subnets. Question number 8 says that which actions are best practices for designing a VPC? So the first right or the best practice is to reserve some address space for future use. Second one is to create one subnet per availability zone for each group of hosts that have unique routing requirements. And the third one is to divide the VPC network range evenly across all availability zones that are available. Now, the reason for all of these answers is that these three reflect smart VPC planning. Always leave room to grow, design around availability zone redundancy, and distribute addresses evenly for high availability and balanced design. Now, if we'll explore the option of match the size of the VPC class CIDR block to the number of hosts that is required for a workload, we are not selecting this one because it's too rigid, leaves no room for scaling. And we are not selecting the option of using the CIDR block as your on-premises network that causes IP conflicts. And we are not selecting the last option to block for subnets in different availability zones that are part of the same AWS auto scaling group. Reason is that each subnet must have a unique range. Now, question number 9 is that where can you have VPC flow logs delivered? So we have three options for this one: Amazon S3 bucket, Amazon Kinesis Data Firehouse, and then we have Amazon CloudWatch. Now, the reason for that is that VPC flow logs capture network traffic details and you can send them to these destinations for storage, real-time analytics, or monitoring dashboards. Each one serves a different operational purpose, but all three are supportive natively. Now let's explore the other options. Like OpenSearch service is not an answer because you can analyze logs, but flow logs aren't delivered directly to it. Then we are not selecting the management console because it is used only for viewing or managing the services. It's not a destination. And we are not selecting Athena because it queries flow logs in S3 but isn't a delivery target. And the last question on module number 9 says that an EC2 instance must connect to an Amazon S3 bucket. What components provides this connectivity with no additional charge and no throughput packet limit? So the only right answer for this one is gateway VPC point. The reason is a gateway VPC point connects to your VPC to S3 or DynamoDB privately without using the public internet, and it's free as well. It routes traffic internally within the AWS and avoid data transfer charges or bottlenecks. Now, if we'll try to explore gateway load balancer endpoint, this is wrong because that's for distributing traffic to third-party appliances. We are not selecting the interface VPC point because it's used for most other AWS services but not ideal for S3. It incurs cost as per the GB utilization, like how much you are using it, and public region access point is not an option because it's not an AWS VPC feature for S3 and it's unrelated. So that was our module number 7 knowledge check. That's it for today.